Hi everyone, welcome to our session today on Women in Data, Nairobi chapter. Our focus today is a guide to text analytics, which will be led by Dr. Lillian. Our main purpose or discussion for the day will be about text analytics, having a general understanding of text analytics techniques, text analytics applications in business, and the key components of text processing. So I'll just do a brief introduction of Dr. Lillian so that she can continue with the session. Dr. Lillian Manzare is a lecturer in the Department of Computer Science at Maseno University. She holds a PhD in computational linguistics from Saarland University in Germany. Dr. Lillian was a researcher in the project Script Knowledge for Modeling Semantic Expectation in Saarland University in Germany as well, between 2014 and 2019, from where she attained her PhD degree. She is an Erasmus Mundus scholar and holds an Erasmus Mundus double degree, MSc in Language Science and Technology from Saarland University of Bolzano in Italy. She also holds a BSc degree in Computer Science from the University of Nairobi, Kenya. Her research interests are in text analytics, knowledge extraction, applications of artificial intelligence, and NLP for under-resourced languages. My name is Paris, and I'll hand over to Dr. Lillian so that she can begin the session immediately.
Thank you, Paris. Hi, everyone. I hope you can all hear me. As Paris has given a brief introduction, our main highlight today is just to try to kind of wrap our heads around the issue of text analytics, or some people call it text processing, others call it text mining, but really, how do we go about processing texts, okay? And it assumes some background, more or less, especially in the tutorial session or in the practical session, some knowledge of programming or Python. I try to give simple examples and more complex examples to kind of balance between the different groups. I'm not sure of everyone's background, but at any point, if you have a question, you can just send a chat, and then I'll see how I can assist you. Okay? So we can just start. A guide to text analytics. Just as Paris has said, we'll look at some introduction on more or less trying to understand what is text analytics. And then I'll go into deeper examples of some techniques that are used in text processing, as some applications in business, and I'll give some practical examples that you can try out later on. They'll be all based in Python. Okay. To start, I'd like to take a step back and kind of, first of all, explain what we mean by natural language processing, because that is really the overarching theme that we want to talk about today. The natural language processing is about how do we build intelligent machines or computers that are able to understand human language. The motivation behind this is, as humans, we communicate predominantly by speaking to one another. Yeah, it will be nice to sort of be able to, speak to our machines, speak to your phone, your laptop, your whatever other machine that you may have. Okay, so think about things like machine translation techniques. Think about how you ask Google for something, like information retrieval and question answering. Think about chatbots. Those are conversational agents. Think about things like converting speech to text and text to speech. That is kind of speech recognition. That is really the overarching idea of natural language processing. But if we nail down to text analytics, it takes a more, I would say, business-oriented kind of side, like more application-oriented, okay? Then really it's just how do you make, unstructured text more useful? How do you reveal patterns from text? How do you reveal insights from text? What can we learn from existing text, okay? And as we all know, there are like numerous sources of textual data. If it was a classroom, I could ask you to name a few, okay? Like what are some of the sources of data that you know? People write on social media, you send SMS, you chat on WhatsApp, you chat on, you send emails, you send complaints and reviews to companies. Yeah. Okay. So all these are sources of textual data. And the main question that business people ask themselves is, what is this value of raw data? Okay. When they received a million, when Safaricom, for instance, receives, a million texts, how do they go about going through them? Hiring someone to read them doesn't really make sense. Yeah. If you are kind of somebody selling your product online, yeah, and people send you chats, how do you siphon through all these millions of chats and get to understand what are they talking about? What are their issues? What are their complaints? What is it that they're talking about? For example, think about this, a ticketing system for emails. Yeah, how can we automatically like categorize that this email or this issue is about, for instance, for Safaricom, my phone is not, my network is unstable at some particular place. How can we channel that ticket to the right water department? Another email could be, my M-Pesa has, I don't know, blocked. How can we channel to the next water correct department? Because they have millions of subscribers. Therefore, they expect millions of water issues. How can they automatically channel this information to the right water department? Or an example, if you're doing market research for your product, you're selling products online and people give reviews. You want to understand what are their sentiments. Do they like your products or do they hate your products? Or for instance, yeah. So really, there's a lot of information that can be gathered around texts that can help us to really make more informed, I could say, business decisions. So that is really the background of where text analytics comes from. How can we be able to get really insights to make us, to help us make more informed decisions when it comes to our business. Okay. Okay. So I'll just quickly move to some examples. So I kind of focused more around classification of text. So really what this means is, for example, what I was talking about, yeah? If you try to understand what is my customer's opinion or sentiment, okay? My experience so far is fantastic. That is good. So really that issue is labeled as what? It's a positive review. Or is it a neutral review? Or is it a negative what review? Okay? So it's really taking a particular text data and giving it a tag or more than one tags that represent the main issue in that what text that you're trying to classify. Think, for example, if you're working for what, a publisher, for instance, yeah, you get many articles, but you want to automatically know before, automatically classify those articles as articles that come into your publishing firm. Are they about technology? Are they about sports? Are they about entertainment? That means you're trying to give it a tag automatically. So when somebody sends you an article to your publishing firm, then automatically it's given a tag, and that is sent to the right person who can review that, for instance, that piece of what article. Yeah, so you are giving a tag to a text. Okay, the same way our emails work. When emails come in, they either go to your inbox or they go to spam. Already, if an email is spam, it's given a tag of spam. That is why it's sent to the spam folder. If it is a good email, it's given a tag of not spam, and that is why it is sent to the inbox. So classification is really about tagging texts with the appropriate tag that represents more or less the content or the issue at hand. Yeah, so you can see there are various applications to it. Another form of classification is what we normally use in conversational agents. Some people call them chatbots. Yeah, that are able to converse with you. For instance, yeah, in the example I've given, somebody is really asking, "How much did I spend on Uber in September?" Now, the system has to understand the intention. What is it that the user is asking? That they can provide the right word answer. So this is called intent classification, yeah? Or an example can also be if you have a chatbot that tries to answer, frequently answered questions, okay? Somebody asks, for example, I don't know which bank, Absa Bank, yeah? Somebody asks, okay, how do I open an account? and you have to understand what is the intention of that question, so that the bot responds with the correct answer after knowing the intention. Okay, so automatically discovering the intention behind a text. So a kind of text classification which is called intent, and is really used a lot right now when you're building what are called the conversational agents, or what we call the chatbots. Now, I like to give some business applications that I'm currently working on. This is just to help you appreciate text analytics. And then in the next 15 minutes or so, we'll go deeper now into really how can these be what achieved. Okay. So right now, let's really just try to understand in general what exactly it is. So I'm working on a project right now that employs text analytics. So what they want to do is be able to extract informative information from, for example, M-Pesa or bank statements, yeah, for them to make meaningful decisions. So imagine that you have such a bank statement, okay? On the red circled part is the descriptions of whatever transactions that you do. On the right side, as the amount of money you spend on withdrawing or on deposits. Okay, it is not enough to just know how much you spent on withdrawals and how much you spent on what deposits. It's very important to know what were you using that withdrawal for, and what were you using that where was the deposit coming from. Okay, so for instance, you find that most of these banks or insurance companies, they provide some kind of loans or insurance. Yeah, they want to be able to segment users into risk levels. Okay, these are more risky users. These are not so risky users, and they use this information. If somebody is, you can see from their transactions. Yeah, for instance, this person kind of purchases from the supermarket a lot, and they are on a kind of income in a payroll, and they just spend on supermarkets. Why do you categorize them? If somebody else gets Fuliza, for instance, and immediately bets with it, what is the risk level of that person? If somebody gets their money and pays mortgages, what is the risk level of that kind of people? If somebody borrows from one bank to pay a loan from another bank, okay? So maybe you borrow from M-Pesa to pay a loan in KCB, for instance. What is the kind of risk level of this kind of people? So the project aims to extract information from the description part of banks and the M-Pesa statements to be able to group people into risk level classes. And we employ a lot of these text processing techniques that I'm going to give you more information about. Yeah. So really, right now, the value of data is high, and not just numerical data, especially the value of textual data. Yeah. And there is more and more companies and businesses are looking at how can we be able to make use of our textual data, and not just the the ordinary numerical data that people are used to processing. Okay, so kind of that is an example of something that I'm working on right now. A second example that I'm working on right now is the issue of extracting, customer, understanding customer emails. Okay, but what this client wants exactly is, if they get an issue, like for instance, I paid for a subscription, but I still have ads and a free version. They want you to split that sentence into various, I'll call them phrases or clauses that represents the various things that are being addressed in that statement, because it can be a very complex and long sentence. So for instance, they want, for every email that comes in, you simplify to the base issues. I have paid for a subscription, I have ads, I have a free account. Okay, so really, so that they're able to find the simplest of issues that a user is trying to raise, and each of these issues is being tagged. Okay, it's an issue about subscription, issue about ads, issue about free account. So they really want to understand the smallest of issue that the customer is raising. Yeah, and really, these are the kind of challenges, because you can imagine there'll be spelling errors. People will be using wrong punctuations. Some people are not native English speakers. They'll be speaking, translated English. Okay. Now, how are you able to process all this kind of text to be able to understand what the customer is talking about? So I hope I have enticed you enough to kind of appreciate what is it exactly when you talk about text analytics and what kind of applications people do when it comes to text analytics. Okay. Up to that, if anyone has a comment or question before we look at really the kind of techniques that are being used to achieve that kind of applications. Okay. If there's anything, you can just send a chat. I want it to be very interactive, be able to see if we are together or not. Okay. So if there's none, I'll just start on some examples of components or techniques that are used to achieve text analytics. The basic thing that you have to do first is to split your sentences. Okay, if you have a long document, you want to understand what are my boundaries of each sentence, because most of this application makes use of sentence level analysis. Yeah, so the first thing is, how do we split our document into sentences, taking care of punctuations, taking care of abbreviation, taking care of long nested sentences. For instance, if it is a conversation, okay, how are you able to split that into the respective sentences? So I will show you in the few minutes on how you do that programmatically. Okay. So the first thing people normally do is just split sentences. So now you have from your document you have sentences. Okay. The next thing you want to do is what we call tokenization. You want to break this sentence into separate individual words. So let me start from here, okay? I hope when it comes to the business application, more or less we have understood kind of its application in business, okay? So I was talking
Yes,
about,
thank you.
okay, we are talking about the various components of text processing, yeah? And the first thing I said was about sentence splitting, yeah? Okay? Trying to split your document into respective sentences. Okay, taking care of punctuations and all the other stuff. After you have your sentence and split, you have to do what is called tokenization. You are now breaking your sentence into individual words or individual what tokens. So the example I have there, the waiter cleared the plates from the table. Now it becomes every single letter is separate from the other. The is separate, waiter is separate, cleared is separate. Yeah. So they're trying to really piece down to the individual words in your sentence. That is a tool that can be able to do when it comes to text analytics. Okay. Another thing that you want to do is you want to know, okay, what are the content words of my sentence? Yeah, because not all words in the sentence contribute to the meaning of the sentence. Some are there for syntactic linguistic reasons, yeah, not really for content. So for instance, if you remove those words that always occur in almost all sentences, they are called stop words. So when you remove them from a sentence, you only remain with the core content words. So in our case, the blue ones are the stop words. So you're only left with waiter, cleared, plates, table. Those are the content words of your sentence. What you have done, you have removed the stop words, where the stop words are what we call the frequently occurring words, okay, that occur in almost every sentence. They don't contribute to the meaning of the sentence. Now, what this enables us to do, for instance, if now you want to look at what are the keywords of your text, you just take the most frequent words after removing the stop words. Those becomes the relevant words or the keywords of your text. Okay. So now other how people build what is called the word clouds. Okay. They just strip down their text, remove the stop words, and then they count how many times the different words occur. Okay? And then what you're left with is what are the most frequent words. Those form part of the keywords of a particular document. So we'll do a simple example of how be able to do this programmatically. Okay. Now, if you notice already, you find that words are always inflected. Okay. Inflection means like a word has suffixes and affixes. Yeah. Well, what you want to do is, if you really want to know what are the words, then it is better to reduce those words to their base, okay? So that instead of counting, for instance, studies, studying, differently. You want to count them as one word. So you can use what is called lemmatization or stemming. They are related but not exactly identical. Okay, that helps you to reduce a word from its inflected form to its base form. Right now, if you do that, you're able to actually now get the actual count of the words that exist in your document, the unique words, after you get rid of the inflections. Okay, you do that by doing what is called lemmatization. So by now, you've broken down our document. It's no longer just a document. It has left from document to sentences to tokens, now to lemmatized words. Like now, they need to, the actual words that are talked about. So for instance, was is the word. If you lemmatize it, it becomes be. If you stem it, it becomes wa. Stemming is always an approximation, especially for difficult languages, yeah. But it always just strips out the last words in a word. So I always prefer using lemmatization. Okay. So studies become study, and studying become also study, the base word. Okay, that enables us to be able to really understand the words in your document. Now we have our base words. Yeah. What else you might be interested in finding out is the parts of speech of your text. Okay, to be able to enable us understand what the text is all about. You want to know what are the verbs, what is the determiner, what are the prepositions, what are the nouns. Okay, knowing these things enable us to do the next things I'm going to tell you about. Yeah, so part of speech is really understanding what is the syntactic tag of a given word. Like that is from high school English or primary English. Yeah, so really have to understand what is the tag, part of speech tag. So if now you know what is the part of speech tag, okay? Interestingly, if you want to really understand the text, you want to be able to get information from the text, okay? Now there is a technique called reference resolution, like finding out what an expression refers to in text. So if you have such a text, Christopher Robin is alive and well. He is the same person that you read about in the book, blah blah blah. You want to know he refers to Christopher who? Robin. Okay? And then you want to know that a boy Chris lived in a pretty home. So you want to know this a boy is Chris, it is the he and is the Christopher what? Robin. So you're trying to really connect the different entities to their to the same the different what the same what person. You're able to know this because you know that, for instance, a boy will have a tag, a noun. Okay, he is a pronoun. I know that nouns and pronouns can refer to some proper what noun, for instance. Yeah, if you know the different tags. So all this enable us to extract information. So here, if you want to, if somebody asks you, for instance, what where did Robin live? You can where did Christopher Robin live? You can know he lived in Catchfield Farm because you are able to put together that this Chris and the boy and he is Christopher what? Robin. It enables you to answer questions from a given text. If you asked how old is Christopher Robin, you can say he's 3 years old because you know that this Chris is the Christopher what? Robin. Okay. So really, it enables us to extract information from text. The other thing it enables us to do is what we call the name entity recognition. Okay, you're also going to use an example of this. So really here, if you want to understand what are the predefined entities in a text, like who are the people in the text, are there countries in the text, is there time in the text, are there locations in the text, you know, those are what we call predefined entities. It will be more clear once I show you an example how to program that. Okay, that is what we call name entity. All this is possible once you're able to tokenize. You do part of speech or reference resolution, then you do entity what resolution on top of it. Okay, so everything kind of builds up to more and more complex what techniques that enable to extract information from text. The example we have here is United Airlines is an organization. You know, Friday is time. $6 is money. You know, for instance, this Tim Wagner is a person. So net entity really tries to look at all the proper nouns in the text and give them a tag. Okay. This is really important for what is called information or relation what extraction. Okay, so I'm building upon all these concepts. Once you do a reference, then you do the entity recognition. Now you're able to extract information from the what text. So for instance, you know that maybe this food tutorials is a kind of entity, okay, and Wes Anderson is a kind of is a person. Then directed is a verb. Then you can extract information from the text and saying that Wes Anderson directed food tutorials. All this is possible because at the beginning, you split the sentence, you tokenize part of speech tagging, you did some reference resolution, okay? Then you're able to, you did some kind of entity resolution. Now you're able to extract it from the what? Text. Like only the necessary information that you really look for. Okay, so everything kind of builds up into the final tasks that now you want to extract information from text. Okay, so I hope more or less kind of gives you an idea of the techniques that you want to use. I'm going to repeat all of them through now practically so I can be able to understand. Okay. The last bit is all this enables you to summarize a what? A document. So you can imagine if you extract the entities on all the text, whatever comes out is like kind of a shortened version of the text with only the key things from the what? Text. You've come from a whole document to a small version of the what? Document. So condensing a text to a shorter version. Okay. And all this is possible because from the beginning, you're able to do the whole pipeline. We call it a pipeline. The whole natural language processing what? Pipeline. From sentence splitting to tokenizing, to part of speech tagging, you know, to for reference resolution, to named entities. All that enables you to do what? Summarization. Okay? Be able to get a summary of your text. So without much ado, we can just start with the what you wanted to do practically. Okay. So I'm going to introduce you to a toolkit, an open source library called Sparsy. So Sparsy is really designed for, optimized for production use, like like real life applications. Yeah. So what the beauty of Sparsy is, it does all the things you've talked about. You give it a text, okay? You pass it through the NLP pipeline. It does everything from sentence splitting to tokenizing to tagging to net entity completely to your document. And you only extract what you need from that document, okay? So let us really see how that works. So let me see. You can tell me if you're able to. Let me share that screen. Just a minute. We talked about sparsity, yeah? So let us just go through all the things you've talked about, okay? So this really assumes, more or less we have some Python background, okay? If something is not clear, you can also just still ask, okay? So the first thing you want to do is to import the sparsity model. For those who wanted to try it out, you have to install Anaconda or Python, okay? But Anaconda contains all those scientific packages for text processing and data science in general, okay? And then on top of that, now you install what is called Sparsy. Sparsy is normally installed using pipe, okay? So you have to do pipe install Sparsy, yeah, okay? Once you import the Sparsy, you have to import the pre-trained models, okay? Of course, all these things that you're trying to do, tokenization, sentence splitting, there is a model behind it that was trained to be able to do that, okay? Especially for English. So for English, we have already, models outside there that enable us to do all those text processing techniques, okay? So we just load the models. So you also have to download them, and then you just load them the way I've said in sparsy.load, okay? So once you load them, now let us start in the next, the first thing, okay? I started with tokenization, really breaking a sentence into separate words. So you can proceed. So working on the first one, you're working on the text analysis one, huh? The IPython one. Okay.
Hello.
So you're looking at now the tokenization part. So splitting a sentence or into respective tokens. Okay. So the beauty of sparsity is once you load the models, you just need to apply NLP on your text. Once you apply NLP on your text, it's able to perform all those analytics techniques I talked about. It does tokenization, identification, and a part of speech target. It does all that with just one command called NLP on your text. Okay, and then when I run this, for instance, you see that it prints out the individual tokens, okay, including the punctuation. Okay, Apple is looking at buying innovative UK startup for $1 million using just the keyword NLP. So NLP does the whole NLP pipeline. Okay, it is the pipeline that we talked about when you're looking at the different stages of text processing. Okay. Again, from just doing NLP on your text, you're able to check out what are the lemmas of my document and extract only the lemmas of your document. So the beauty of sparsity, everything is represented as a hash, okay, dictionary or a hash mapping. Okay, so it enables you to access every individual process by just calling the token. And if you want the text or the lemma or the part of speech or you just call it. But everything is kind of it uses the hashing technique. Okay, so if I run this for token in document, print for me the text, which is like Apple. Print for me the text dot lemma, the text dot the part of speech, which is the post, and then explain to me what that tag means, the post tag. In our case, Apple is looking at buying innovative UK. Apple, the lemma is just Apple, and it's a proper noun because that is Apple, the company. Okay, is the verb or the word. Okay, its lemma is be. Okay, which is just an auxiliary verb. Okay, looking is the text. Look is the lemma. It's also just a what? A verb. Okay, so just by doing NLP, you're able to get all these steps performed on your text. Okay, so you can see that buying, the lemma is buy. Innovative, the lemma is just innovative because it's an adjective. Okay, UK is a proper noun. Startup is a noun. Okay, you can say that a billion is a cardinal value, and the full stop is a punctuation. Okay, the dollar sign is just a symbol of currency. So really, it kind of breaks down your text, okay, by just having to do one line, which is you perform natural language processing on your text. So for instance, if I say I wanted to extract, I don't know, nouns and adjectives, okay, I can just say for every token in my document, yeah, if that token is, the part of speech of the token is a proper noun, save it for me in some list, okay. And if the part of speech is a adjective, put in the adjective words list, such that when I run this, it kind of gives for me all the words that are proper nouns and all the words that are what adjectives. You can think of whatever thing that you want to do. Okay, so it enables us to kind of map all those aspects of our text. Okay, so we are now understanding more or less what is this text about. We can do the same to stopwords, yeah. So you have to load the stopwords. So it is this command of sparsity.language, the English stopwords. So you call sparsity, you call the language is English, and then you want us to load the stopwords. There are many languages in sparsity. Sadly, there is no African language. I don't think there's only Swahili. I'm not sure even if it is there. Okay, but you're able to load the stopwords. So let us look at some examples of stopwords. So in sparsity, there are around 326 stopwords like do, done, if, seemed, as. Okay, if I run again, you can get another set: across, go, fast. Okay, So these are just derived from large texts, and they look at, like, the top 300 most occurring words. Those become what? Stop words, for instance. So it's just a dictionary of a list of words. You might think about it. So that means if I want to extract only the words from my text that are not tokens, I just want to extract all the tokens from my document where the token is not a stop word. Yeah, its stop word is false. Okay. So what that does is, this is the original sentence. Apple is looking at buying innovative UK startup, and then this is the list of tokens without the top words. You see, is has been removed, at has been removed, and I think for. Okay, so you only have the content words. We still have punctuations though. We haven't removed the punctuations. Okay, the punctuation can also do the same way. You just call the same function. Token is punct or is punct is false. So you only want to select those tokens where it is not a punctuation. Okay. Now if I combine all that, what we now left is this. Okay. After you do tokenization, you remove the stop words, you remove the punctuations, and you lematize. What is just left is the final tokens: Apple, look, buy, innovative, UK startup. So this is now our kind of the contents of our document, our short document. Any questions so far? So I'll just proceed. As I started out with the tokenization, but again, if you have a longer document, or if you have such a long text, okay, Gabi is a Python developer currently working for Nairobi-based fintech company, blah blah blah. You still perform the same NLP on the long text. Remember, NLP performs the whole NLP pipeline from sentence splitting to tokenization to part of speech tagging, plus others that I haven't talked about. Okay, so it really does all those on your provided text. Now, if I want to look at what are the sentences in my text, okay, I just call my sense, and I say, okay, from the NLP, give me all the what sentences. Yeah, and if we run this, we get the individual sentences. Yeah, every sentence has been split correctly. So we have 3 sentences from our document. Okay, so just by doing NLP, you're able to perform the whole NLP pipeline, and that's why Spassy is quite applicable, especially for people who don't have to really worry about the nitty-gritties of the other issues of natural language processing. Okay, so now we have split our document. So you can imagine, if you have this document, you can also print out the tokens. For every sentence, we'll print out the words, the tokens. For every sentence, you can remove the stop words, you can remove Okay, so we are at word frequencies. Okay, so I keep on moving between the presentation and the chat just to see if someone's asking a question. Okay, so if you want to now just look at the word frequencies, now we just get all the tokens from our long document. All the tokens will now be our words. Okay, and then we count how many words we are. So in this first part, what I have done is I have just tokenized it. I have not removed any punctuation, I have not lemmatized, I have not removed any stop words. So if we run this, we see we have 23 words. Okay, even a full stop is counted. There are 3 full stops. There is, there is there is Python, there is she, there is Gabi, developer. Okay, so here I've just only the tokens. Okay, we have 23 raw words, more or less, or raw tokens. Now, if I remove the stop words and I remove the punctuations, okay, what I am left with now is just 15 words. Okay, because now, as you can see here, we don't have the full stop, we don't have the stop words is, we don't have are, and all the other punctuations. So now we only have the words, only the content words. So you can just achieve that by saying, for all my tokens, I don't want tokens that are stop words, I don't want tokens that are what? Punctuations. But give me every other token. Okay. So that allows us to get the number of words in our document. You can go a step further, and now we just don't remove the stop words, we now lematize. Okay, as you can see here, working is counted separately, and also works is counted separately. But if you lematize, now you can see we have only 14 words, because now work has been lemmatized and now it's counted as one word. Now, if you now want to know what are the top most frequent words in your document, you can now just call, top 5 most frequent or most common. That gives you like Python and work. So if you had a longer document, you can imagine be able to extract and see what are those keywords in your document. Okay, so that is more or less from, if you have a long, I'll repeat that. If you have a long document, you perform the sentence splitting on the document. Yeah, you can be able to extract all the tokens and be able to remove the stop words and the punctuations from all the tokens, and be able to lematize, and that allows you to get the most frequent words in your document. Okay, so far so good, I hope.
Yes, thank you.
Okay, now let us try to look at some applications. I'm already running out of time for the next half of the presentation. If you wanted to do like named entity recognition, okay, so now you have a really long text, a longer text. Yeah, again, you can just call NLP on your long text. The beauty NLP does the whole NLP pipeline. That is the beauty of sparsing. Now we are not looking at the tokens. We want to get the entities. Okay, let me run this so that you can see the entities. For instance, it has identified that this Sebastian Thrun is a person. Okay, Google, which is here, is an organization. 2007 is a date. American is a nationality. All this. Let me visualize this. If I render this, it gives you a nice view of your document where all any entities are what highlighted. Okay. Now, if you want to do relation extraction, you can just say, for instance, this Sebastian Drew started working at Google. Okay, or Sebastian still started working at Google on this particular date. So all this is possible because we run NLP on our document. Behind the scenes, it did sentence splitting, tokenization, part of speech, and everything, and now enables us to extract the entities from the text. Okay, and now you're able to see what is your text talking about, who are being mentioned in the text. So the text is about this Sebastian guy, and we're looking at Google and something about it, more or less. Okay, so that's really one application. The last application that I'll talk about in this first half is text summarization. Okay, for text summarization, we need something extra to enable us to do that. We need to install this. It's called text seed. It runs on top of sparsing. Okay, requests enable us to get data from a web address. Okay, request. Beautiful soup enable us to extract information from a web page or an XML from a web page. So I just combine those two. Okay, so imagine you want to know what is Wikipedia Kenya talking about. So our URL is just a Wikipedia document for Kenya. So we asked requests to get for us the contents of this URL. Okay, so it goes online and gets the contents of the URL. and then we get only the content. That is the next part. You get the contents. Then the contents of the URL, we pass it through Beautiful Soup, yeah, and Beautiful Soup only extracts the text part of your document. You can do more with it, but mostly you can just want to extract the text part. Of course, it's a Wikipedia. It has, if you're familiar with the HTML, there's a lot of tagging going on behind the scenes. So there are some tags that you're not interested in, okay? You don't want the metadata, you don't want the head or whatever other tags you don't want. So I'm just going to remove everything that is in this blacklist. I don't want those tags to appear. So only give me the text part of all the tags in the HTML page whose parents are not in my blacklist. Okay? So when I run this, just a minute, the output, it takes some error. What is the error again? Or requests, I didn't run requests, sorry. So I have to run this one first. I have to load the requests first. Okay. So now you've loaded the requests. Okay. So the output, you can see, it has taken everything in our Wikipedia page. Okay. Sorry. It's just all the data on the Wikipedia page. It's a lot of information, you can imagine. The history of Kenya is all in the Wikipedia. So just by using request and Beautiful Soup, you're able to extract information from a web page. Now let us do NLP on that web page. Okay. So we do NLP on our output, okay, on our Wikipedia page. And then we use this text to extract for me the key information that I want from that document that talk about what Kenya, for instance. Okay. All of them are going to be statements in the form of subject, verb, and then the fact about that statement. So the cool thing about this is when you run that, it takes a bit of time. When you run that, NLP behind the scenes is able to perform the whole NLP pipeline. And then the text is going to extract semi-structured statements from our document that talk about what? Kenya. Then what you have is just a list of summary of the Wikipedia page, okay? That says, like, Kenya is the world's 48th largest country, 29th most popular country, is the home of the famous Safari Rally, commonly acknowledged for the toughest rallies in the world. So really, it enables you extract like a summary of a web page that you're looking at, okay? That enables you to really, in a nutshell, just get the gist of what the page is talking about. And all that is possible because you're able to do the whole NLP pipeline using Sparsy, and on top of that, use Textasy to extract the semi-structured information from our document. Okay, so that is really just to entice you to try out and see what you can be able to extract from different pages of your choice. Any questions so far for the first half of this presentation? So I hope, of course, you cannot learn everything today, but I hope the presentation gives you a kind of, zeal. You want to learn more about, text analytics in general and practicing in different applications. There are many tools outside there. One of them is just Sparsy, but there are several other tools that exist that also enable you to do text analytics. Okay. Question or comment so far before I start the second half?
Hello, Lilith.
Yes.
Thank you for your presentation.
Yeah.
It looks very, very intriguing. And my question really was about how you implement Sparsy in normal, basically your normal work, day-to-day work. Because the tools, NLP, processing and text analysis.
Yes.
So I know you can actually take an offline dump and then you run the tool on it and do your language processing.
Yes.
And now you've talked about something which is interesting, which is HTML parsing, and then basically look at that. But have you done an integration with an application before? Like, for instance, if let's say you know there's data entry clerks log into a certain tool of choice or an application in a bank, for instance,
yes,
and then they're capturing data. Do you have any situation where you have run this on the background interfacing with that application through some APIs?
Yes,
and then this, it's possible. Yes, so just give us an idea about that, and so that you can have some expectation as well. Thank you so much.
Okay. The beauty, one of them is, all of this, it's kind of, the main question is how do you, once you have your model, for instance, yeah, how do you expose it out as an API, for instance, if you so wish. Okay. So the fun thing about most NLP, you find that you get, like what you said, you get a lot of data, you build your tool, which is a more or less kind of a machine learning model. Okay, the only thing you need to do is to expose that. Okay, and now that is another level of how do we expose our tools. Okay, so it's really there are already tools there which you can be able to talk about in another session, now in a more practical session. Okay, that you can be able to use for that. Okay, so I'll just leave my email after this, and anyone who has some specific question like this one, we can talk about it, in a certain, because some people it will be too high level for them for this particular meeting. Okay, but we can take up that with you if you're interested.
Okay, thank you very much.
Yes, I'll give my contacts after that.
Yeah.
Anybody else?
There's a question in the comment section. How will
Okay.
one deal with not text objects, i.e. like emojis?
So there's actually an emoji parser. Okay, actually emoji parser. Those are two different issues. There's actually an emoji parser, and also one of them is actually on top of parsing that enables you to decode emojis. Yes, that is another application area. If you are into emojis, yes, there is an emoji parser for that. Okay, but that's another area of trying to decode what an emoji is all about. It's another area of interest for some. For some. Okay. Okay. So if there's nothing specific about what I've presented, then I'll start with the second half. Okay, so we talked about sparsity and NLP and the whole NLP pipeline. Of course, there are many things going on behind NLP, but because of time, I've only picked a few. Okay, so try and see what else is behind NLP. Now, I promised to do an application on text classification. Okay, now to be able to do any kind of modeling on text, of course, the language itself, we as humans are able, or we as people, we're able to understand the text. Like a dog in heat needs more than shade. That is just a sentence. But we know machine only understands zeros and ones at the low level. Okay, how are we able to transform our raw text into a representation of something that a machine is able to compute? That is what is called text representation. Transforming text into something machines can understand. In principle is we are reducing our text to a vector. A vector is just, an array of numbers. We might just simplify, okay, to vectors. I'll give a very simplistic example. So for instance, there's a model called bag of words. You take a sentence and then you can imagine we do NLP on it. You're able to tokenize it. And then maybe you perform lemmatization if you so wish, or you remove the top words. Okay? And then you just count for every document how many words exist in that word document. Now that is possible if for every word, think of it as you create a dictionary. Okay? So you have your sentence, a dog in heat needs more than shade. You extract all the words in the sentence, and then you create a dictionary mapping of all the words. So for instance, you can say dog is position 0, need is position 1, cat is position 2, blah, blah, blah. It is very important. The first thing you have to do is to create a vocabulary or create a dictionary representation of all the words in your text. So that when the machine looks at word 0, it knows, like in any document, if it sees word 0, that is a what? A dog. This word 1, that is a need. Okay? So imagine you have such a text. Okay? We have two documents, document 1 and document 2. The quick brown fox jumped over the lazy dog, and now is the time for all good men to come to the aid of their party. You combine all your documents and extract all the words using NLP. When you select all the words, you tokenize, you lemmatize, you remove top words, blah, blah, blah. And then you form a vocabulary of your words, okay? That is the term. So all the terms in your documents, that becomes your vocabulary. Now, because it is a fixed dictionary, you know that position 1 is for word 8. Position 2 is all, 3 is black, 4 is brown, such that you can represent document 1 by a 0 or 1 that represents the presence or absence of a word in your dictionary. Okay? The document 1 will be 00110111 blah blah blah, depending on which word it from the vocabulary exists in that word document. Document 2 again will be 11011 blah blah blah, depending on which word is in that word document. So in a way, you have transformed your text into a vector. So instead of each document being just a series of words, each document is a vector representation that kinds of captures what words exist in your document. Okay? In a simple way. That is what is called like the bag of words model. It's the simplest of document representations. Right now, there are more complex techniques that use what we call embeddings that are based on neural networks that really capture not just the presence of the word, but also captures on top of it the meaning of the word. Okay. So maybe later on I can have a session later on about just word embeddings and vector representation in terms of complex techniques, not just a bag of words. Okay. So there's a question. Okay, I'll answer that one also. Okay. So that is a bag of words. So really, you cannot perform any machine learning model on a text without representing the text numerically. That is number one thing you have to do. So let's assume, just picture in your mind that you're converting your document into a vector of numbers. It can be very complex numbers, but at the end of the day, it's just a vector of what? Numbers. That now represents your document. So now you have represented our document. So imagine you have to find out if documents are similar. Okay, you can just perform a maybe cosine or dot product similarity to see which documents are most similar to the other. Okay, because now every document has been represented by just a series of numbers, and you can just count how many overlaps are there in words between documents. The more the overlaps, the more similar the words, the text. The less the overlaps, the more different or distinct the words, the text. Okay, so really representation enables us to do textual similarity and cluster documents into groups of documents that are similar. You're able to group them because they will tend to have the same distribution of words if they are similar compared to the ones that are more different. Okay, so you can imagine if you have a document about sports, a document about restaurants, of course their words will be different. About sports will be more towards the sports words, so they'll be grouped together, and about restaurants is about the more food related words. So just by doing a simple bag of words model, we're able to group similar documents together, okay, by using text representation. What I want to talk about is text classification. Examples I gave before. Imagine the question somebody asked. You want to train a chatbot to ask specific questions and send feedback. Okay. The first thing you want to do is to be able to, because it's I'm not sure if you have machine learning background, but let's say you want to train a text classification. One thing you need is the text itself. The second thing you need is the tag to that word text. Classification is a supervised task. That means you have to have both the text and the tag. Then the model learns how to associate the text and the word, the tag. So for instance, you want to train a model and be able to decide if something is a restaurant or is a sport. So you give it many texts with the tag sport and many texts with the tag word restaurant. Okay. Then you do feature extraction on the document. Feature extraction just means you transform the document from just text to a vector of what? Numbers. Once you have the vector of numbers, you use any machine learning algorithm for classification. I'm going to give you an example. And then you have your classifier what? Model. So the basic thing is you have your text, which is tagged. You transform the text into features, which is just a vector representing the text. You plug your features and the tag in a machine learning model to help it associate which words belong to which tag. And then you build a model classifier. Now, once you have the model, what can do now? If you have a new text that you don't know its class, okay, you again take the text, perform feature extraction, which is just transforming it into a vector, and then ask the model, okay, this text I've given you, what is its tag? The model gives you a what? A tag. For instance, you give it text X, the model, you ask the model what is the tag of this text, and the model will say, is it either a sports text or a restaurant what? Text. Okay. So that really enables, you really have to have what is called the training data. The training data is for training your model, and then you have kind of the test data, what you want to test to see how good your model works by asking it questions about the text, and it produces a what? A tag. And you're able to test if the tag is correct or not what? Correct. Okay? That is how more or less it works. So this is a bit more complex than the previous set of examples. So there's no question. I can go to the notebook and then we go through a simple text classification example if there is no question so far. Good. So in your mind, just think about what we talked about. If you want to classify a document, you have to have the document and the tags for that document. You take the two, you extract the features, which is that transforming the document from a text to vector. You plug the features into a model that learns to associate the features of a particular tag, and then you build a model. Once you have your model, you can ask your model questions. You provide a given text, you ask the model, what is this text about? And it gives you a what? A tag. Okay? That is more or less in really short what we mean by classification. So here, we want to classify some research papers. Okay? So you know that there are many research publications, journals. Okay? So you want to know if you have a text, and you know which journal it belongs to. So the data is here. Okay? So let me show you on that. So first I import pandas. I hope pandas is just enabling us to process CSV kind of files. The NumPy enables us to do some numeric calculations. Matplotlib and Seaborn are for plotting. Okay? But those ones you can learn with time. So let us look at this data. So you look at this data. This is the text. So this text belongs to this conference. This text, another conference. Okay. So you can see from our representation, you have the text, and then you have the what? Tag. The title is the text. The tag is the what? Conference. So you have those two. Okay. So we have our title, we have our text. That means we have our text, we have our tag. The first thing we want to do is we want to be able to split this data into what we are going to use to train our model, and then what you're going to use to test our model. Okay. So when you're trying to build a classification model, we have to really know how our model performs. That's why we divide it into training test and testing test. Okay. Set. There is skitlearn. Skitlearn is also a function, or what? A toolkit, if you want to call it, that enables you to perform machine learning. So it's called sklearn. Sklearn contains many machine learning models, from classification to clustering to dimensionality reduction to whatever kind, okay, of models they are existing in skitlearn. And they're not just used for NLP. They're used for main data science and all the other, image recognition, all the other fancy stuff out there. You're able to do them from scikit-learn. If you're into machine learning, you can try and check out scikit-learn. So it has a function called train test split. So I'm just splitting my data 0.33%. That means 70% of it I use it for training, another 30% I use it for testing. Okay. So if I run this, you see that it contains around almost 3,000-ish documents. I have reduced it to just training set, around 1,600 of them, and for the test I use around 800 of of them. Okay, and the conference is called IFCOM. So let me just show you that in a picture, but that is faster. These are the number of documents in that text. Okay, so from IFCOM you have around 500 or so. Another one you have 300. So every text belongs to one of these categories, one of these conferences. So you want to build a model that is able to predict if a text belongs to which conference. Okay, in a nutshell. Let us start the training process. Like we said, I will import many things. You not learn them today, but just to kind of entice you to learn them more. The first thing you want to do, let me start from the non-text, is this part, yeah? You want to clean your text. You want to vectorize your text. Then you want to do what? Train your classifier. So cleaning the text here means you perform NLP on the text. You remove stop words, you tokenize, you lemmatize, you sentence split, whatever is necessary. That is part of the cleaning. Once you clean it, you vectorize. Vectorize means you transform it into a what? A vector representation of your words. Once you have your vector, the thing to do is to be able to do what? To classify. Now, there are many tools outside there, but I've stuck to either Skitlearn or Sparsy for this example. Yeah, like I said, Skitlearn has many machine learning techniques. One of them is called a feature extraction. There are many feature extraction. The simplest one is the bag of words. The bag of words is called a count vectorizer. It just counts the number of words in the document and say it's there or not. Okay. Then enables us to transform it into a particular able to perform a particular vectorization technique by transforming the text. Pipeline just able to build a pipeline. You don't need to worry about them so much. And then I've chosen a linear model called logistic regression that helps in classification. You can choose any other model that you so wish. Support vector machines if you want, or just a kind of decision trees. There are many models that exist, but this is one of the simpler models. Okay. Good. So again, we do the same. We load this. We load our NLTK. We load our data. We are working on English text. We load our stop words, and you want to use them. I won't worry so much about the second code. What it only does is it kind of cleans the text by doing tokenization. It transforms the text by doing vectorization. And then the fit is, it classifies, it builds the classifier by the fit method. Okay? In a nutshell, so first we clean the text. Clean the text means we are just removing unnecessary new lines. We are lemmatizing. We are removing the stop word list. We are removing the symbols. Okay, we are taking it to lowercase. That's what we mean by cleaning up the text. Once you clean up the text, we transform it into a vectorizer, and then we fit it to a model. Okay. So let's build our vectorizer first. I've not loaded it. I have to load it here first. So I didn't run this one first. Okay. Then we can now load our vectorizer. Okay. So vectorizer is just this count vectorizer. Okay. The vectorizer is text input, the tokenized text. Okay. That you have defined up here, the tokenized text. And then our classifier is just the regression model. When you call our pipeline, what we do is we clean the text first, we vectorize it, and then we classify it. The same procedure: clean text, vectorize it, classify the text. Okay. We had already split the text into training set and test set. So if you remember from our diagram before, you have the text, you have the tag, you extract features, which is the vectorization. You put both of them into a machine learning model, you get your words classifier. Okay, it's the same high level idea of it. Okay, pipe.fit is what calls the classifier. I have to run this too fast. So I load the classifier, then I load the data, then I perform classification. So what a classification does is just it takes our training data, which is the train, it takes the tag, okay? It combines those two, which is just here, the training data and the tag, okay? It takes those two and builds a model. What I've done here, I've taken the training data and the labels or the tags. I pass that to my fit classifier. So what this does is it just trains a model that is able to learn to distinguish different conferences from each other. Okay, just takes the text and then the tag, only those two. Now once you have the model, now this is our model. Okay, now we have our model. What we want to do next is we take the testing data, extract features, we ask our model gives us a what? A tag. Okay, that's what we have here. Let me just run that. This part, pipe predict test, is what we have just explained in this diagram. You take the text, you pass in the model, it gives you prediction. Okay, what we have here, we have the test data, we pass through the model, it gives us what? Predictions. Then I look at the predictions one at a time. Okay, if that prediction is the same as the original label, okay, that is correct. If the prediction is not the same, that is what? Incorrect. And then I just count how accurate is my system. So the example is here. Like in the first one, the system predicted that it is a VLDB, which is what? Similar to the correct what? Label. In the second data, the system predicted this SG graph, but in truth, the real label for it is what? ISCAS. That is what? Incorrect. So you just go through all your predictions and count which are correct. And then our system is 75% what? Accurate. Okay? So we have come from building the model and then using the model to make predictions on our test data. And then we compare the predictions that are made by the system against the actual labels or the actual tag of our text. That enables us to estimate how accurate or how good your system is. Okay, as you can see, our system is not good. It's not so good. What can we do? You can go back and reprocess the text and try different techniques. Instead of using a simple count vectorizer, you can use a more complex representation, for instance. Yeah, you can add more data. You can, there are many things you can be able to do to improve your model words performance. Okay, that is just in a nutshell how you're able to kind of take your text, okay, transform it into a vector representation, use that vector in a model to build a classification model, and then use your model to predict. Now, once you have this model that someone asked, you just need to build an interface to expose your model on the internet so that someone can come and ask your model a question, then it gives a what? An answer. Okay? So the training part is normally offline. Once you've built a model, you expose your model out for others so that the ones using your model really don't care how the model works. They just want to give the question and they get the what? The answer. Okay? The techniques of exposing your model to be used in the public by others. Okay. Before I wind up, questions first. This has been rather intense, but we have time to discuss. You can ask any from any part.
Yes, there is a question from Kelly. What percentage indicates a model?
There's nothing as vague as good. The reason I'm saying that is it depends. This is really a theoretical answer first. So before I go to the real answer, it depends on how good the humans are in that task. Okay, that's from a theoretic perspective. For instance, yeah, if I am trying to build a system that is able to correctly determine what type of document is this, okay, and human beings find it very, very it's a difficult task even for humans to distinguish. Yeah, if you have what is called the human upper bound, okay, if the humans perform like at 70%, your system performs at let's say 65. That is a very good system. Okay, But if it's a very simple task, humans get 100%, a system gets 6, that's a very bad word system. Okay? And then it needs to get more than 90%. Yeah? And there's always something called the human upper bound that determines how good a model is. That is the theoretical aspect of it. Now, if you come to such an example, for instance, there are many techniques of measuring how good a system is. So what I've shown you is just classification, is just accuracy. Accuracy is the simplest model that says, just count for me how many times something is correct or not correct. Accuracy tends to be biased depending on the distribution of the number of items in the classes. Of course, it goes with the majority. Okay, so you can imagine if you have a system that it's supposed to predict if somebody has cancer or no cancer. Okay, and in your data set you have like in the real world, you have like around 90 million people, but only 1 million have what? Cancer. Yes, and then 90% don't have, but 10% have. Now, if your system always just say don't have, it will 90% what? Correct. Or is it a good system? You know, because there the issue is it is more important to get those who have than to say it's worse to say somebody does not have cancer, but yet they have what? Cancer. So for that system, it is important to get this 10% what? Correct. Okay. So really the issue of goodness of a system always depends on what is your target problem. So in that case, your system is 90% correct by just guessing everybody doesn't have, but it's just guessing. It is more important that it gets exactly who has the what? The cancer, for instance. Okay. The other techniques that you have, one of them is accuracy. So accuracy just measures the percentage of total predictions our model makes that are completely what? Accurate. But then there's the issue of precision and recall. Okay. Now precision is this. I'll stick with the cancer because it's easier to explain it like that. If out of all those cases that your system have said to have cancer, okay, how many of them actually have what? Cancer. That is how precise your system is. If your system says 10 people have cancer, out of those 10 people, how of them actually have what? Cancer. So if 10 out of 100 of your system have said 10 out of 100 have cancer, out of those 10, 8 of them truly have cancer. The system, how precise is it? Okay, is 8 over the number of people that have cancer. The other aspect is recall. Recall is this. Out of all the people who have cancer in the data set, how many of them your system actually said they have what? Cancer. Or if you're noticing the difference. Okay. So recall measure is your system able to capture all classes correctly? Okay. Out of everybody who has cancer, how many of your system actually say they have what? Cancer. That is recall. Precision means out of all those people the system said they have cancer, how many of them truly have what? Cancer. So if you combine precision and recall, it kind of tells you how good your system is. It's always a better measure than that using what? Accuracy. So combining precision and recall gives you a measure called F-score. Okay. So if I run this part, there's something called F1 score. Okay. F1 score, you can see that it kind of gets for every class. Yeah. So that means if your system was just guessing, it will not, the accuracy will be high, but the precision and recall will be what? Low, because it's calculating for every particular class data set. How good is it in knowing that VLDB is different from ICAS? You can see that it performs very well with ICAS, but performs poorly in what? WWW data sets. From this, it enables you to see for every class how good your system is. It's better than just saying accuracy in general, okay, in a nutshell. So really, that is the two main ways you can be able to tell if your system is okay or not. Theoretically, think of the upper bound. How is the humans? One, and what is the problem domain? What is more important for you in your system? That determines how good you measure, the measure of goodness of your system. someone else? I hope that more or less makes sense.
Yeah, there's another question from Juma. What technique can I use to classify into multiple binary outputs such as 1000?
Okay. When you say multiple binary outputs, such as 1000, what exactly do you? I'm not sure I get your question.
I was referring to a case where you have multiple, the outputs are labeled, or the tags are labeled, such as maybe cancer. In case you have multiple labels, such as maybe cancer, you can talk of maybe cancer, diabetes,
Mhm.
yeah, such like you can not just 1000, but
Yes.
one, in case it is present, then it's a one. If it is not present, it's a 00. Such like binary output.
Okay, I get you. Okay, so you are asking a kind of a multi-level situation. Okay, so for instance, if I have a text, it is very okay for the text to be like, for instance, you classify emails. Okay, an email can be, it is not spam. Okay, the same email is a work email. The same email is about I don't X topic. So this email has more than one tag. I hope that is what you're referring to. Okay, we're trying to classify reviews. A review is about, let's say, Safaricom bundles. A review is positive. A review is urgent. So that means one particular text has many tags. Okay, I hope that is the correct interpretation of your question. Okay, so that is called. So this, what I've done is just a two-class problem. Okay, true or positive, they are not positive. But in real life, there are many things that have multiple what labels. The only thing that changes is your how you pass it to your model. Okay, so in your modeling part, you don't just pass one output, one tag. Okay, you pass several tags, and there are different techniques. Okay, one of them is called one versus all, or one versus rest. What it does is this: behind the scenes, okay, instead of building one classifier, it builds 10 classifiers depending on the number of classes. If you have 10 classes with 10 classifier, and then every classifier gives a prediction for your data, and the output becomes, for instance, 1000. It means that one is there, the others are not what there. Output can be 1010. That means one and one are there, the other zeros are not what there. Okay, so yes, what changes really is how you kind of define the model. Okay, that is called a multi-class. Okay, so there's multi-class and there's multi-label. So multi-class, it means you have many classes, but each data has only one label. Multi-level means you have many classes, and every document has a possibility of having more than one what tag. Okay? So if you're looking at the multi-level problem, it's more than one tag and many classes. And then multi-class is just many classes, but every document has just one word label. So yes, there are tools for that, but are not covered in this, completely not covered here, but they are there, yes. Okay.
Then Stephanie is asking, are there same algorithms for basic machine learning used in NLP, e.g. decision trees?
Yes. So like, for example, in our example here, when we're doing the classification, yeah, it's here. Okay. Let me just show you here. When you're defining your model, okay, you go to split lines, you can actually replace this line with any model, a decision tree, a Bayesian kind of naive Bayes model, support vector machine, any model that is able to do classification, of course, not any, but within the classification models, yeah, and be able to replace that here. So for instance, here I can call naive Bayes instead of logistic regression and see how it performs. So yes, any machine learning classification that exists there can be used for text. The question is, will it work well or not? That is the question. But principally, yes, any can be used for machine learning. Yes.
Yes, there's another question from Juma. Some websites with JavaScript's block beautiful soup, can it be modified to overcome this?
Well, some website block web, it's called web scrapping. In principle, beautiful soup does it's a web scraping kind of tool. Okay, so yes, some websites have login, some websites block it. Some people, have a kind of a wrapper around it. I don't know how legal that is in extracting information from it. Yeah, but yes, of course, some websites don't allow like web scraping from their sites. Yeah, okay, well that's another issue altogether. Okay, that is my email. You can always send me a message if you so wish.
Thank you for attending our session, and kindly check out our meetup group for more events. Every event will be posted there so that you can check out our next event. Thank you very much. My name is Paris and I was your host.